Hello and welcome. This is part two to the 1 3/4 rule of perspective. The first one goes through a much more technical description of how we got to this point. In this part, we are going to kind of continue this and come up with a method that's very quick and easy to use and should be more like a shortcut. So let's kind of look at this kind of in a little bit of a quick review first. This right here is the cone of vision laid upon the picture plane, which is a square box here. This circle could be bigger to include all of the picture plane here. We've got it in kind of a little bit of a smaller area. And this is the area where, when we use our perspective points, that will come up with an undistorted view. This is the helicopter view of our object. Here we've got a rectangular building, and it's kind of off-centered a little bit. So that the front's not facing directly to the picture plane, but it's kind of turned at a little bit of an angle. The distance from this point down to here to the station point is about 1 3/4, and this is how we get the name of the rule, the 1 3/4 rule. And this distance is basically the radius of our cone of vision times the tangent of 60 degrees, and the tangent of 60 degrees is approximately 1 3/4. Then what we do is we take any of these lines that we've got. So on this side of the building, we draw a line starting at the station point that's parallel and go up to where it crosses the horizon line, and that gives us a vanishing point. We take the other angle, or the other side of the building, which is along here, and draw a line that's parallel to this from the station point up until where it crosses the horizon line, and that gives us the left vanishing point. So what we end up with is this. Now, what we could do then is take a look at this in a little more detail. This angle that we're tilted here, which I call theta, is same as this angle right here. And if we use trig again, we can find out that the distance from here to here is going to be the tangent of this angle times this leg right here, which is a tangent of 60. In other words, if we go up here, it tells us that it's the radius of our cone of vision times the tangent of 60 times the tangent of that angle that our building's tilted at. Tangent of 60, once again, is 1 3/4. So what I can do is do different angles here and kind of come up with a tabled value. The other angle over here, since this building is at a 90-degree corner here, this will also be 90 degrees here. So I can take this angle and subtract it from 90 to give me this side, which gives us this other angle over here. And then we can calculate this out similarly. The radius times the tangent of 60 times the tangent of 90 minus that. Well, most of the time we're going to end up with using either the building at a 45-degree angle to us or a 30-degree angle to us. And you'll notice that here it's approximately 1 3/4. Here it's 1 3. So these are pretty easy numbers to memorize. And there's some more in here if you have different angles that you're tilted at. But also keep in mind that being art, what we do is we come up with this approximately, and then we kind of adjust it for what looks good to us. So don't think you have to actually do this so mathematical that it chokes you. So let's take a look at an example. And what we find out is we really don't need this station point anymore because we're just finding these distances. So let's get rid of that. So let's say we have this building tilted to us at about 30 degrees. Then if we use a thumbnail sketch of about 2.5 inches, and the reason we're using 2.5 inches is because what we'll find out is that it's almost, well, it is impractical in some cases to get a vanishing point that's so far out away from the canvas. So what we can do is we can do a thumbnail sketch, and from the thumbnail sketch be able to take the proportions and go to marking it off onto our canvas. In another video on planning, I'll show you how to take a thumbnail sketch that's in proportion to your actual canvas, and then using proportional dividers, be able to transfer that onto the canvas without having to have these long extensions out to our vanishing points. If we're at 30 degrees here, 30 degrees times a radius of 2.5 inches here, and that's the radius of this. The canvas is going to be a little bit bigger, but this radius, let's say, is 2.5 inches. Then we look into the table and find 30 degrees, and we notice that it's going to be for our left vanishing point times 3. So vanishing point left is 3 times the 2.5 inches, which gives us 7.5 inches. So we measure from our center of vision here out 7.5 inches to find this vanishing point. So for the right side here, we have 30 degrees, and we go up to the table, find our 30 degrees, and it says it's a multiplying factor of 1. So the multiplying factor of 1, we multiply 1 times 2.5, which gives us 2.5 inches. So we measure from our center of vision along the horizon out to our 2.5 inches, and that gives us that point. So we can see is that it's just a very simple task here. Once we have a table of values, and you can do your own table. Here's the equations, but usually you're just going to be at a 45 or this 30-60. Now this table works also kind of in reverse, and that is this angle here, instead of being 30 was 60. Then what happens is we reverse these two columns and reverse these two columns. So then our right vanishing point becomes a 60 degrees, and it's the multiplying factor of 3, and our left becomes the 30 degrees and a multiplying factor of 1. So we've got more than just the table listings here, but we can reverse this also. Another thing to take a look at is, had we had a third angle in here, we would have to go from our station point to where we crossed our horizon. And what we notice is that if we take a look at the angle, we can still use this table to find that third vanishing point for a third side that's at a different angle. So anyway, this gives us a quick and easy way of finding these vanishing points using the 1 3/4 rule, or based on that. And I hope you enjoyed this, and that it will help you find those vanishing points for appropriate locations very quickly now, without having to just guess at it and arbitrarily put in vanishing points. Thank you for watching this video, and good luck to you.